This is just the shortcut on how you can be able to be finding the isomerism or number of isomers between alkanes from butane to heptane. So here, what you should do is, let's replace this n with 4. Let's start with butane. So I'm going to have 4 minus 4. I replace the n with 4, then plus 1. Now 4 minus 4 is 0. I'm going to have 2 raised to the power 0, then plus 1. And anything raised to the power 0 is 1, then plus 1. Okay? And 1 plus 1 will give us 2. That means butane has 2 isomers. Butane has 2 isomers. The first one is the normal butane, which is the first isomer. The second one is the 2-methyl propane. So if you use this formula between C4 to C7, you will know the number of isomers of pentane, hexane, then heptane. So let's look at the structure. The structure of butane is like this, okay? But keep in mind, this formula only works for carbon from C4 all the way to C7. So this is the structure of butane. So let's look at the isomerism if you want to know how to draw the isomer. I will replace this methyl at the end with the hydrogen by jumping 1 carbon atom. So if you jump 1 carbon, okay, so what I will do is I'm going to be left with 3 carbon atoms, because this other one at the end will now turn to a branch. So I will carry this bunch and bring it down to this place to replace the hydrogen. So let's write the hydrogen at the end. Then methyl will now be brought down. So here is the CH3 that we carried from the right side. Okay? So fill other places with hydrogen atoms. So in this case, we now have the second isomer of what? Of butane. So the first one here, which is the N-butane, look at the molecular formula. It is C4H10 because there are 4 carbon atoms and 10 hydrogen atoms. The same is true for the second one. They have 4 carbon atoms and they have 10 hydrogen atoms. So you see they have the same molecular formula, which is definition of isomerism, but the structures are not the same. So the structure for the first one is CH3, then CH2, another CH2, okay, then lastly CH3. So this is the structural formula for butane. Now let's look at the structure formula for this 2-methyl propane. You have CH3, you have CH, then CH3, okay, then lastly CH3. This carbon has a hydrogen and also a methyl from what we have drawn. So lastly, I'm going to put this CH3 at the end. Look at the structure of the 2-methyl propane and the normal butane. They are not the same thing, but they have the same molecular formula, which is definition of isomerism. So the name of this is 2-methyl propane. Okay, isomerism is the existence of a carbon of an organic compound with the same molecular formula but different structural arrangement. Thanks for watching and have a nice day. Anyway, keep in mind that this formula only has effect from carbon number 4 in alkanes to carbon number 7, but for alkane groups. Thanks for watching and have a nice day.